So now that we've learned how to write the system of equations from nodal analysis, our next task is to solve that system of equations so that we can determine what the node voltages are. Now, I've shown here, this is a matrix set of equations that we're going to solve, and I have pre-written the MATLAB commands that we're going to use to solve it. Before we do that, I just wanted to mention things to look for in this matrix. You should notice that the diagonal terms should all be positive. If you find that there's a diagonal term that is negative, in fact, even if there is a component of a diagonal term that's negative, you've made a mistake in the algebra, or in the circuit analysis and in the passive sign convention. And then all of the off diagonal terms. So these are what we call the off diagonal terms. Those should all be negative. And so these are things that you can check just by looking at the sign to see whether or not things are likely to be correct. There's one more thing to know, though, and that is that the off-diagonal terms will be symmetric. And so when you're looking at these, if you reflect the off-diagonal terms across the diagonal, you'll see that those are going to have exactly the same values. And since you write these three equations separately, this is a really good way to check if you've made an algebra mistake. I'm going to say 80 to 90% of algebra mistakes can be caught just by simply checking to see if your nodal analysis matrix is symmetric. And then, of course, over here on the right-hand side, every element in that vector should come from a current source that's in the circuit. So I can tell you, even though I don't see here in front of me the circuit that was used to create this matrix, I know that there's at least a 4 amp source and a 2 amp source that was used in that circuit. Okay, so here we can see the command that creates the matrix. Notice, for example, that this is the first row right here, and you just put spaces between elements on the same row, but you have to have a semicolon in between the rows. Here's the second row, semicolon, and here's the third row, and then that's the end. And then for the vector, because it's 3 elements in 3 separate rows, we have to have a semicolon in between each of those. Then we're going to take the inverse of the matrix and multiply it by the vector. Think about if we put the inverse of the matrix over here, well, if that inverse multiplied by the matrix, that would cancel each other out. But then you also have to put the inverse of the matrix right here as well, and then that will multiply by the vector. There are other ways to solve this set of equations using MATLAB, but I think that this is the most foolproof way. So let's see how we can actually do that in MATLAB. Now I've actually typed these in already, so you don't have to watch me type. So here you can see the matrix. And as I type in the matrix, because I didn't put a semicolon at the end, it's going to echo the matrix back to us. And that's helpful, I think, because you can see if every cell is in the right place, make sure that it's still symmetric and so forth. And then here's the vector. So you can see the vector. Yes, that's a column vector rather than a row vector. And then we can calculate the solution. And the solution gives us 3 numbers. Those 3 numbers correspond to V1, V2, and V3. So as soon as you get those numbers, you've already identified the node voltages. I can go back over here into my original assignment sheet and scroll down, and you can see these are the V1, the V2, and the V3. So this is a way that you can do it using MATLAB. Now, you're probably not going to be carrying MATLAB around with you in your backpack everywhere that you go. You will be carrying your calculator with you everywhere you go. And rather than create a video for your particular calculator, I'll post a couple of videos right next to this one so that you can see examples of how your calculator can be used to solve those equations. Or just if you have an unusual calculator, just type into YouTube, search for matrix solutions and then the name of your calculator, and then you should be able to find what you need.